All right, let's talk about something you see all the time, but maybe never really looked at: GPS coordinates. It's the language that runs pretty much everything, right? From your phone's map getting you to a coffee shop to tagging your photos. It's everywhere. We're going to break down that string of numbers and turn it into a real, actual place on Earth.
Okay, so let's just throw one out there. You look at this, and it just looks like a secret code, doesn't it? 51 degrees, 39 minutes, 10.4 seconds north. I mean, what on earth does that even mean? How can that pinpoint one single spot on our massive planet? Well, stick with me because by the end of this, you'll be able to read this just as easily as a street address.
But before we can crack that code, we've got to understand the map it's written on. See, every single GPS coordinate out there is based on this invisible grid that's wrapped around the entire globe. So let's break that down first. First thing you need to picture is the equator. Think of it like the Earth's belt. It's our main starting line, running east and west, and it sits right at 0 degrees. It splits the world perfectly into the northern hemisphere and the southern hemisphere. Every single north or south measurement, it all starts right here. And if the equator is the belt, then we have the prime meridian. This is our vertical starting point, also at 0 degrees. It runs from the North Pole all the way down to the South Pole, right through Greenwich, England, fun fact. And this line splits the world into the eastern and western hemispheres. These two lines, they're the absolute foundation of everything. So here's the big takeaway. It all boils down to two things. We've got latitude, which tells us how far north or south we are from the equator, and we've got longitude, which tells us how far east or west we are from the prime meridian. Put them together, and boom, you've got a unique address for any spot on the planet. Okay, so now that we've got the grid down, let's get back to our mystery coordinate. It's time to actually break this thing down piece by piece. We're going to crack this code right now. So let's tackle this first chunk. This part right here, this is our latitude. This whole section is doing one job and one job only, telling us our exact position north of the equator. And this is where you see the different layers of precision. Think of it like zooming in. The 51 degrees gets us in the right neighborhood, 51 big steps north of the equator. But a degree is a huge area. So to get more precise, we break each degree into 60 smaller pieces called minutes. We're at the 39-minute mark. And for really pinpoint accuracy, each minute is broken down into 60 seconds. We're at 10.4 seconds. And that little n at the end, that just confirms what we already know. We're north. All right, on to part 2, our longitude. Just like before, this whole chunk is telling us our position. But this time, it's all about how far east or west we are from that prime meridian. And guess what? It is the exact same logic. We start with the big jump, 89 degrees to the east of the prime meridian. Then we zoom in to the 52nd minute inside that degree, and then we zoom in even tighter to 34.8 seconds for incredible precision. And the E just confirms we're in the eastern hemisphere. See? It's a system that just keeps getting more and more accurate the deeper you go. Okay, so we can read the numbers. That's awesome. But what do they actually mean? Like, on the ground? How far is a minute or a second in the real world? This is where it all clicks, and these numbers become real, tangible distances. You see, when we're going from degrees to minutes and then down to seconds, we're not just playing with smaller numbers. We are talking about real-world distances. Each step down in that scale brings us closer and closer to a specific physical point on the ground. It turns that abstract grid into a place you can actually stand. And check this out. A single minute of latitude, that's not some tiny little measurement. It's equivalent to 1.85 kilometers. That's just over a mile. So yeah, that's a pretty significant distance. But then you get down to a single second. And this is where it gets crazy precise. 1 second of latitude is about 30.7 meters, or around 101 feet. This is how GPS can get you right to someone's front door. It is literally all in the seconds. So let's bring it all home and apply this to our original coordinate. Those 39 minutes north we talked about, that represents a journey of 72.1 kilometers. The extra 10.4 seconds adds another 319 meters on top of that. And for our longitude, those 52 minutes east translate to about 96.2 kilometers, and the final 34.8 seconds adds roughly another full kilometer to that. So when you put it all together, what that long string of characters is really saying is this. Okay, go find where the 51st degree north and the 89th degree east cross. Got it? Now from that exact point, travel 72.4 kilometers further north, and then travel 97.2 kilometers further east. And that is how you find the spot.
And just like that, it's not a secret code anymore, is it? You've learned the language. From the equator to the prime meridian, from the big degrees down to the tiny pinpoint seconds, you can now officially read the Earth's entire address system.
So I'll leave you with this thought. Now that you can basically find the address for any spot on the entire planet, from the top of Mount Everest to your own childhood home, where's the first place you're going to look up?